Hello and welcome to my introduction to the gas laws. My name is Bernard Taylor and this is Fez Physics. Why Fez Physics? Because I am the physicist. Get it? Okay, Boyle's law. If we have a bicycle pump and I put my finger over the end, I can increase the pressure and I decrease the volume. But of course, if we're going to be taking measurements, we need something in the way of a little bit more sophistication. And we'll see that we have Boyle's law apparatus as used in many schools and colleges. Incidentally, if we increase the pressure on something and then suddenly release it, we get some interesting results. Or indeed, these packaging bubbles, and if I... Wow, what a noise. So, that's my introduction to Boyle's law. Let's move on. What about Charles' law? Well, what I've got here is a plastic syringe. I've melted this end to seal it, and at room temperature, which I can measure with my thermometer, I can measure the volume. I then put it into a mixture of water and ice at 0 degrees centigrade. I leave it there for a good few minutes to so that the gas inside, the air inside reaches 0 degrees centigrade. And of course, remember, that's 273 Kelvin. And a little bit of encouragement might be needed, but yes, the volume does decrease. Having taken a measurement of the volume at that temperature, I can take it out, put it into freshly boiled water, and earlier this was at about 85 degrees centigrade. I can always check the temperature, and this time, yeah, the volume has very definitely increased. So, what does Charles' law say? Charles' law says that the volume is directly proportional to the absolute temperature. Now, you can do this in your college or at school, and I can get 3 points. One at about 0 degrees centigrade, one at room temperature, perhaps 25 degrees centigrade on a good day, and 85 degrees centigrade. Now, if we're lucky, we can take those points and ... extrapolate back to absolute zero, if we're lucky, on a good day. So, volume is directly proportional to the absolute temperature, Charles' law. Okay, now, what about the pressure law? Well, I'm not going to do much here, except to issue a warning. Here I've got a cylinder of compressed gas. The fact that it's flammable adds a little bit of piquancy to what I'm saying. But if I was to put this on a gas stove and heat the cylinder, what would happen? Well, of course, the pressure of the gas would increase, and there would be a likelihood of an explosion, a catastrophic explosion. So don't try that at home. Now, one more bit of fun. With this little bit of apparatus, it's essentially like a piston. Here's the barrel of the cylinder, and here's the piston itself, which is going to go in there. Now, what am I going to do? I'm going to take a little bit of used tissue. It's quite clean, really. I only used it once. And I'm just going to push that. Yes, I push the bit of paper down to the bottom, and I'm going to put the piston in there. There's the handle. Now I want you to watch the base of the cylinder where the paper is. Why? Because Boyle's law says that the pressure of a gas is inversely proportional to the volume, provided the temperature is constant. And there's something else about gases and temperature. If we compress a gas very quickly, we do work on it and its temperature increases. And let's see if that happens. So I'm going to go 1, 2, 3. Oh, nothing much. But there was a little bit of smoke, but perhaps there's no smoke without fire. So I'll try that quickly once more. And setting things up quickly, and I'm going to stand up for this and see if I can whack it a little bit harder. 3, 2, 1. Yes! Isn't that wonderful? So, if we increase the pressure on a gas quickly, its temperature increases. Conversely, if we have a high pressure gas, and such as in a carbon dioxide cylinder, and we release the pressure quickly, there's a fall in temperature. So, one case we're doing work on the gas, in the other case, the gas is doing work. Now, that is my introduction to the gas laws. So have a look at my next Fez Physics video and keep working. Thank you very much.